So lug angle is nothing but a small angle. So first I'll write what is lug angle and then I'll explain by using a diagram. So first write along with me. It is a small length. It is a small length angle. It is a small length angle which is used at joint location. Which is used at joint location to make outstand leg. To make outstand leg as connected leg. Connected leg. So this is lug angle. So it is a small length angle which is used at the joint location to make outstand as a connected leg. So I am going to show it in the diagram. So see here, this is a gusset plate. This is a gusset plate. So to this gusset plate we have connected an angle. Okay, so here we connect this angle to this gusset plate either by using weld or bolt. Okay, so these are the bolts. So this is an angle connected to the gusset plate by using a bolts. Clear? So now if you observe, this is a connected leg and this is outstand. So unconnected leg here is called as outstand. We know that. Okay, unconnected leg is called as outstand and this is a connected leg. Now to make this outstand as a connected leg, we have to use lug angle. Okay, to make these outstand or unconnected leg as a connected leg, we have to use lug angle. So by making use of lug angle, we are making it. So how do we do it? So if you see the lug angle is a small length angle. So it is having very small length. So this is lug angle. So this is how we are going to use connections. So this is lug angle. So this is a cross section. So if I show the longitudinal view, okay, if I show the length view or longitudinal view, so the length view or longitudinal view we can see like this side view. The reason the length of this member is perpendicular to the board. So if we want to length view, so if we want length view or longitudinal view, we have to see from side like this. So then we can see the length. So how that longitudinal view looks like? Let us see. So this is the gusset plate. To this we have connected the main angle. So this is called as main angle. Okay. So this is called as main angle or main member. Main angle. This symbol indicates length continuous and it is going to take a tensile force of P. Okay. So now here where we are going to use lug angle. So this is lug angle in this case. This is lug angle and this is main angle. Agree. So now to connect this lug angle to the main angle, we are going to use the bolts. So obviously the bolts are here like this. Agree? And then these are the bolts which are, so here we have used the two lines of bolts. Agree or not? So in each line we can assume as many as we wish. So here I am going to take 2. Okay, so these are the bolts used for connecting these one leg of the angle to the gusset plate. Okay, main leg of the, so one leg of the main angle to the gusset plate. And here we have to connect these lug angle to the gusset plate again by using bolts like this. Agree? So this is the connection. So this is how the longitudinal view looks like. Okay, this is how the longitudinal view looks like. So now here I am going to give the numbering. So the number of bolts, okay, number of bolts required for connecting the one of the leg of main angle to the gusset plate is N1. Okay, and the number of bolts required for connecting lug angle to the main angle or outstand of the main angle are N2. Here I am representing N2. And the number of bolts required for connecting lug angle to the gusset plate are N3. Agree? So here I am writing N1 number of bolts required to connect main angle to gusset plate. To connect main angle to gusset plate. Gusset plate. Next, N2. So what is N2? Number of bolts required to connect main angle and lug angle. Main angle and lug angle. Now N3. So yes, N3 I will write here. I will write here itself N3. Number of bolts required. Okay, number of bolts required to connect lug angle to gusset plate. Lug angle to gusset plate. Agree? So now here if you observe, the bolts are the connections used for connecting the lug angle to the main plate. Okay, lug angle to the main plate should start in advance of other connections. So if you observe here, the bolts which we are used to connect this outstand to the lug angle are going to start in advance in comparison to all bolts. Yes or no? So that is the one of the provision. Okay, so here the important provision you should remember here is the bolts which are connecting lug angle to the main angle should start in advance in comparison to the other joints. Okay, it should start in advance in comparison to the other connections. Clear or not? So how many connections here? So this is one connection, this is one connection, this is one connection. So what are the connections? Bolts for connecting main angle to the gusset plate, that is one connection, and for connecting gusset angle, for connecting the lug angle to the main angle, that is another connection, and for connecting lug angle to the gusset plate, that is another connection. 3 connections are there. So in all these connections, among all these connections, the connections which are connecting lug angle to the main angle should start in advance. Agree? That is the thing. So now if you observe here, as by using lug angle, now the outstand can also behave as a outstand, can also behave like a connected leg. Agree or not? So if outstand behaves like a connected leg, what happens? Come on, tell me. If outstand behaves like a connected leg, then what happens? We can eliminate shear lag effect. Agree or not? We can eliminate shear lag effect. So if you remember, the net design tensile strength of an angle based on net section rupture. So if you remember that formula, what is that formula? Tell me. TDN. Okay, design tensile strength of angle in net section rupture. TDN. What is that formula? 0.9 FU by 1.25 into A and C plus beta into Fy 1.1 into AG not. Agree or not? So now no need to use that beta here. Agree or not? No need to use that beta. There is a no shear lag effect. As this outstand also behaving like a connected leg, no need of shear lag effect. And that too, one more advantage of using lug angle is, here by using lug angle we can reduce the length of the connection or not. As we can reduce the length of the connection. So whereas if there is no lug angle, then length of the connection can be increased. Okay, length of the connection can be increased so that more gusset material has to be used and more bolts are to be used. Agree or not? So what are the advantages of using lug angle? By using lug angle we can eliminate shear lag effect and we can reduce the length of the connection. Agree or not? These are the advantages. But there is a major disadvantage of using lug angle. What is that use of lug angle? More material has to be used. Agree or not? So one lug angle and the connections here N2 and N3 are to be used. Agree or not? So because of these connections, okay, because of these fastenings or connections, this becomes uneconomical. Okay, usage of lug angle becomes uneconomical. Even though it is going to eliminate shear lag effect and going to reduce the length of the connection, but because of using more bolts and the lug angle, the consumption of material becomes more and it is uneconomical. Based on that, nowadays we are not using lug angle. So lug angle nowadays is obsolete. Okay, lug angle nowadays is obsolete, or you can say outdated. Lug angle nowadays is outdated. We use these lug angle in working stress method. In limit state method, nowadays we are not going to use more widely. But this is a provision. So if at all lug angle is provided, so that we are having some advantages. What is that advantages? We are going to eliminate shear lag effect and the length of the connection can be reduced. But if you observe in the formula itself we are using beta, so that beta will take care of shear lag effect. So no, don't worry about the shear lag effect. Okay. So that is the thing here. So now if we come to the design of lug angle. So if we see the design of the lug angle. So what is the total force that is coming on to this member P? So this is the P. So P is nothing but factor tensile load. Okay. So now total force. Total forces are factored P. So now force in connect. F connect. What is meant by F connect? So force in this connected leg. F connect is nothing but force in this connected leg. So force in this connected leg is nothing but P by AC plus A naught into AC. What is this AC plus A naught? AC is the area of connected leg. A naught is the area of outstand. Of course, in previous sessions we have discussed how to calculate it. Yes or no? So how to calculate this? So divide it like this. So this is T and this is T. Agree or not? So if you multiply this, so we have discussed in yesterday's class, this is W1, in previous class W1 and this is W. So this length is W. Okay, this length is W. Clear or not? Now to get the area of this connected leg, so if you multiply W1 into T, we are going to get this total area. Agree or not? And if you multiply W into T, we are going to get this total area. So there exists overlap. Agree or not? So based on that, what we are going to do? We are going to divide it like this. Half. So total area, if you take this as a square, T into T is a T square, total area overlap. So by half, T square by half. So this is T square by half. Give it to this connected leg and this T square by half, give it to the outstand. So in this way we can calculate area of connected leg and area of outstand. So how to get area of connected leg? W1 minus T by 2 into T. So that we discussed in previous session. And how to get this? W minus W2 into T. That is how to get A naught. So that is what? P by AC plus A naught into AC. So AC is nothing but area of connected leg and A naught is nothing but area of outstand. Okay. So this is the force in connect. Means force in connected leg. Now force in outstand or out. So how to get it? Total force by AC plus A naught into A naught. So this is how to get force in outstand. Okay. So now design force. Design force in lug angle. Okay. Design force in lug angle. F is equal to 1.2 into F outstand. Okay, 1.2 into F outstand. So this is if we use main member as angle. So this is for angle. So this is for angle. And if we use in place of angle, if we use channel, so in place of angle, if we use channel, then it is 1.1 F outstand. So this is for channel. So this is the design of lug angle. So for that force we have to design. So if we use angle, then the design force of lug angle is 1.2 into outstand, force in outstand. If we use channel, then we have to take 1.1 into outstand. Agree? So take it up. Okay, so now how many bolts required at this connection and at this connection, at this connection? How to calculate it? So let us see. So I'm going to rub this N1. So N1 is the number of bolts required at this location. So at this location means number of bolts required to connect the main angle to the gusset plate. So it is F connect means force in the connected leg by design strength. Design strength of bolt. So what is the design strength of bolt? Design strength of bolt is the minimum of design strength of bolt in shear, bearing and tension if it exists. Agree or not? So out of those three, whichever is minimum, that is considered as the design strength of the bolt that we have discussed in bolted connection. So F force in outstand by the design strength of bolt gives us number of bolts required. Agree? Next, N2. So what is N2? Number of bolts required to connect the main angle to the lug angle. Agree or not? So there is one provision regarding this. What is that provision? This connection should start in advance of all other connections. Agree or not? So that N2 is 1.4 F outstand by design strength of bolt. Next, N3. So what is N3? N3 is the number of bolts required to connect lug angle to the gusset plate. Agree or not? So now N3 is 1.2 F outstand by design strength. Design strength of bolt. Agree? So this is how to decide. So these provisions is for angle. So if we use angle as a main tension member, then this is the provision. But if we use channel, now what is N1, what is N10, what is N3? Okay, so if we use channel, we know how much force to be used for the design of lug angle. So if we use channel, we know how much force to be used for the design of lug angle. How much it is? 1.1 into force in the outstand. If it is angle, 1.2 into force in the outstand. But these are the number of bolts required for angle only. So if we use angle, okay, angle as a main member, then this is the case. But if we use channel, then what is the case? So that I will show or we will discuss by drawing a diagram. So I'm going to rub this diagram, the angle diagram. I'm going to show a channel, and then I'm going to show how many rivets are required or bolts are required. So this is the gusset plate. So to this gusset plate, we are going to connect a channel. This is the channel. So here we have connected the channel to the gusset plate by using a bolts like this. And to make these two flanges which are outstands here, to make these two flanges which are outstand as a connected, okay, as a connected flanges, then we have to use the lug angle. So like this, we are going to use lug angle at top and bottom. Clear? Okay, so here these two are called as lug angle. So this is a main channel, our main member. So this is a main member, which is channel, and these two are the lug angles. Now if I show you the length or longitudinal view, so this is the gusset plate. So these two are the flanges and length continues, and this is the force P. So here we have used the lug angle. So as we discussed the connections. So as we discussed the connections which are used to connect the lug angle to the main member should start in advance. Agree or not? Should start in advance. So they should start in advance. So after that, okay, this is the connection, and here clear. So this is the channel. Okay, so this is the channel used as a tension member. So to make that flanges, outstand flanges of channel as a connected flange, we are going to use two lug angles. Agree or not? So we know that in this case, for how much force we have to design lug angle? So we have to design the lug angle of force 1.1 F outstand. Of course, this we discussed. Agree or not? So now here it is M1. It means number of bolts required to connect channel to the gusset plate. Next, these are N2. So what is meant by N2? Number of bolts required to connect channel to the lug angle. Agree? And so these are N3. What is N3? Number of bolts required to connect lug angle to the gusset plate. Agree or not? So how many N1? So what is the value of N1, N2 and N3? Let us see. So N1 is nothing but F connected by design strength of the bolt same. It means force in the connected leg, or you can say the connected web. Okay, connected part of the channel by design strength of the bolt. And N2. So N2 is nothing but number of bolts required to connect channel to the lug angle. So it is 1.2 into F outstand by design strength of the bolt. Next, here N3 1.1. That's it. So if each channel, these are the provisions. So that is the diagram. Okay, so here we have used the channel. So this is the main member. So main member is nothing but channel. So if each channel, this is the provision given by the code book. So take it down. So this is about the design of tension, design of total tension members. Okay, so in this tension member, either we may use lug angle or we may not use lug angle. But as I said, nowadays lug angle is outdated or obsolete. So no need to use of lug angle nowadays. So simply the procedure what we have discussed so far or before this, simply use it. So if we use angle, use that formula. What is that formula for net section rupture? Design tensile strength in net section rupture, TDN. What is that formula? Come on. So remember, what is that formula? Recollect. What is that? 0.9 Fu by 1.25 into ANC plus beta into Fy by 1.1 into Ag naught. So simply use that formula, design it. So just remember it. Okay, just remember it. So this is the design of tension members. So we have discussed in detail. So if we solve some numerical, so that you'll understand with much clear. Okay, so you understand this concept with much clear.